Hello students, welcome to the Interesting Chemistry, where you will find a feeling of classroom teaching. If you want to enjoy classroom teaching from your study room, then please watch the video of Interesting Chemistry. In continuance of the quantum number, it's my second video. In my previous video, I have told you about the quantum numbers, that there are 4 quantum numbers. One is principal quantum number, azimuthal quantum number, and third one is magnetic quantum number, and fourth one is spin quantum number. Again, I am telling you the principal quantum number, azimuthal quantum number, and magnetic quantum number, and spin quantum number. So there are 4 quantum numbers. The principal quantum number and the azimuthal quantum number have been explained to you in my previous video. So today I am going to explain the magnetic quantum number and spin quantum number. But these magnetic quantum number are not independent. They are the integral part of the azimuthal quantum number, and azimuthal quantum number is integral part of the principal quantum number. So we should recall about the principal quantum number are the n, the 1, 2, 3, 4. It means the first cell, second cell, third cell, and we can also call them K with the name K, L and N. K, L and M. So here, and again the second one is azimuthal quantum number. So the value of azimuthal quantum number L is equal to 0 to n minus 1. Here I want to tell you that how will you get to know the number of subcells in a cell or a suborbit in an orbit. So here this one is cell, this one is subcell. Azimuthal quantum number tells us the number of subcells in a particular quantum number, 1, first, second, third. So in this L, so here if you will put the value of n is 1, then 1 minus 1, 0 to 0, it means first cell or the first orbit has only one subcell. And again, now come to this point, the magnetic quantum number, the symbol of magnetic quantum number is M. The values of M is equal to minus L to 0 to L. Minus L. So here, if I want to calculate, I will find the value of for the first quantum number, the value is 0, and again here you will put 0 to 0 to 0. So there is only one orbital, that is S. I will give you this in a form of table, but try to understand first. So here again the third point is the special. So the magnetic quantum number tells us or describes us the orientation of the electron cloud with respect to the coordinate axis, set of coordinate axis. As you know, there are 3 axes, the x, y, z. When an electron cloud revolves around the nucleus on the x-axis, then this form is V, then y, this is x, y, and this is z. So this also tells us the orientation of the electron cloud. As I told you in my previous video, that the shape of the electron cloud, of the p orbitals or the p subcell is a dumbbell shape. So do you visualize, did you ever visualize How can say the shape of the p orbital or the px orbital is a dumbbell shape, or the shape of the p subcell is dumbbell shaped? So I will explain you. I am trying to explain you. So when these subcells, the electron revolves around the nucleus, and in this subcell it is elliptical, oval shaped. It is not in round. P subcell, the shape of the p subcell is elliptical or oval shaped in this form. So in between, in the center of this cell, there is a nucleus positive charge. When this electron clouds come nearer to the positive charge, so this elliptical or the oval shaped path gets twisted like this. So here is nucleus, and you will see here in the, so the path of the electron will be like this and this and this, and here it is nucleus. When you will see in this form, now it looks like a dumbbell shape. So you should visualize about the dumbbell shape. So I hope that you have understood what is the dumbbell shape. So in this way, the orientation or the shape of the electron cloud in the p subcell is dumbbell shape. When the electron cloud revolves in x-axis, it is px. When revolves in the y-axis, it is py. When it is revolves in the z-axis, then it is pz. So here, then here n cell, n is the principal quantum number. N is the, so it is called as cell, and again it is orbit. L is the subcell. L tells us about this subcell or this suborbit. So here the SPDF are the suborbital, or these are called subcells, and M tells us the orbitals, only orbitals. So these orbitals are px, py, pz, and orbital for D, dxy, yz, zx, dx square minus y square, and dz square. So these are the orbitals. Now I will tell you how will you find the value of these subcells and orbitals in a particular cell, so whether it is 1, 2, 3 and 4. Here again I am telling you, this is the combined structure of the cell. So in the one, suppose I am telling you the 2p. In the 2p there is S and px, py and pz. So it is S. So it is S. This one is S. S is in the round, in the form of a round or a circular form. The shape of S is in the circular form or round form. So this is 1S, and this one is 2S, and this one is 1S. So here this area is for 1S, and this area is for 2S. So this shows the 1S and 2. I can impose this, but the structure will be very complicated. So to make you understand, I explain separately about the 1S and 2S. So it is, let's see here. Again I am telling you that I told you X with a wire, that this is X. Suppose this is electron from this side and this upon and this electron will go from this side. So this one. In this way, the electron comes here, suppose here again, and this will this and come to this way. And again, this electron comes to this way, come to this way, and this again, and this. This is the way. In here, the nucleus is in the central part. This all the electrons revolves around the nucleus. Now I am going to tell you about that how will you calculate the value of these different. There, as I told you, this again, please recall it, that N tells us the cell, that 1, 2, 3, 4 OGKLNM, and L tells us the subcells about SPDF, and these SPDF have these orbitals that are defined by Px, Py, Pz, Dxy, and so on. Now I am going to tell you that how will you find the values of different NLN. Suppose I am telling you that they are telling you the how to find the value of L, N, and M in the first cell or first orbit. This is N, this is L, this is M, this is M, and when N is equal to 1, suppose N is equal to 1, then find the value of L. So here you will put the value of N 1, so 0 to 1 minus 1, it means 0 to 0, it means there is 0. It is 0, the value of L is, it means first cell, first orbit has only one cell, subcell. First orbit has only one suborbit. First cell has only one subcell, and that is S. That is S. Again, now when we know the value of L, then calculate the value of M. This is the, when you will write here minus 0, 2, 0, 2 plus 2, 0, so it is again S. It is again S. So here you can say 1S. This 0 tells us there is only one orbital in the first cell, in the K cell. If I ask you, find out the number of orbitals in K cell. K cell means the first quantum number, the first cell. K means first. So the value of K is equal to 1. Then you will find 0, and this one is 0. So this is M. Now come to the second point here. For the second cell, here N is equal to 2. Suppose this is N is equal to 2. N is equal to 2. Here it is 2. Then find out, this is the principal. Now you have to find the value of azimuthal quantum number L. So here, when it is N is equal to 2, you will write here N minus 1, 2 minus 1, 0 to 1. 2 minus 1, 0 to 1. So you will write here 0 and 1. It means, it tells us, because the value of L are 2, 0 and 1, so it tells us that the second or the M or the second cell contains two subcells that are 0 and 1. These are the subcells 0 and 1. This is again S and this is P. So these are the subcells. Again, subcells it is 0. Again you will find the number of orbitals for S. Number of orbitals for S for this 0. You will find 0 as I told you here. Because 0, 2, 0, 2 plus 0. Minus 0 to 0, it means 0. Again, when you will write here that P, here you will write minus 1. Here you will write minus 1, minus 1, 2, 0. It is 0, 2 plus 1. B plus 1. How will you find the value of minus 1, 0? Because principal quantum number 1, so the value of L is equal to 0 and N for 1 P, for when L is equal to 1, when L is equal to 1, then the value of M will be minus 1, 0, and so this again tells us Px, Py and Pz. This tells us the Px, Py and so here from this chart you have found the values of P subcell P orbitals. There are 3 P orbitals. Now how many total orbitals are there in the second quantum number or second cell? There are 4 orbitals. So 1, 2, 3 and 4. There are 4 orbitals in the third one. Now I am telling you about, sir, I think that you have understood how will you calculate. Now I will telling you about the third quantum number. So it is the third quantum number. It is third quantum number. Can find the value of L. How will you find the value of L for the third? 3. The first and is equal to 3. Then find the value of azimuthal. Find the value of L. You will put here 0, 2, n minus 1. It means 3 minus 1. 3 minus 1. So 0 to 2. 0 to 2. So the value of L for 0, 1 and 2. The value of 0 to 2. N is equal to 3. 3 minus 1 T 2. 0 to 2. 0, 1 and 2. Now again you have to find the values of, as I told you previous, the 0, here it is 0 and here for 1 minus 1, 0 and plus 1. Here 2. Here 2. You will write here for the M, for the values of M, the value, find the, if I say you that find the value of M, if the value for the L is, the value of L is equal to 2, so we write here minus 2, minus 2, minus 1, 2, 0, it is 0, and 0 to plus 2, so here plus 1, then plus 2. There are 5. So these are the dxy, dyz. There are 5 orbitals of the d. So in this way you can calculate you can find the value of the n plus l. So this is about the azimuthal quantum number. Then how will you find the value of azimuthal? This tells us, so when you have to write about the azimuthal quantum number, magnetic quantum number. So the magnetic quantum number, the symbol of the magnetic quantum number is m. The values of m is equal to minus l to the plus l. And this also shows the spatial orientation of the electron cloud with respect to the coordinate axis. These coordinate axes, that is px, py and pz. Now how there are, now if I ask you how many orbitals are there in the if n is equal to 3, if n is equal to 3, how many orbitals are there in the third cell? So we will count here 1, 2, 3, 4, 5, 6, 7, 8 and 9. And again directly you can calculate with the n square. This is the number of orbitals. N square tells us the number of orbitals in a particular cell. If n is equal to 1, there is only one orbital. If n is equal to 2, there are 4, as I told you in my previous that S, Px, Py and Pz. And now in the third cell there are S, Px, Py, Pz and dx. These are the 5 orbitals of the d. So there are 9 orbitals. 3 square is equal to 9. So in this way you can find the value of the number of orbitals in a particular quantum number or particular cell. I think that I have explained you and you have understood. Now I am going to tell you about the spin quantum number. As you know, there are two electrons in an orbit or in an orbital. Suppose we write here that px. Suppose we write here px2, py2 and pz2. There are two only, s2, one s2. It is all there. One orbital, each orbital contains only 2 electrons, s2, px2. So total you write here p6. There are 3 orbitals in the p, so it is p2, px2, py2 and pz2. So total 6 electrons are there. So now question arises, both the electrons are negatively charged. Both the electrons are negatively charged. How can they exist in an orbital? They will repel to each other. So here I am telling you that each electron has 2 types of motion. One is circular motion, and second one is axial motion. Please try to understand what I am going to tell you, that the circular motion and the axial motion. When a electron revolves around the nucleus, it is circular. But this electron revolves round the axis. It revolves round the axis. When it revolves around the axis, just like the earth. Earth has 2 types of the motion. One is earth revolves around the sun, and again it has also a axial motion which revolves with the axis, around the axis. So in the same form, electron has 2 types of motion. One is circular One is circular motion, second one is action. So this action motion may be, suppose one electron revolves in this way and the second electron revolves in this way. This is clockwise. Clockwise. And this is anti-clockwise. So I am telling you again, the circular motion. So as I told you, the two types of the axial motion. So here this is electron. It is the axis, and it is here. It moves in this direction, and in this way, here this electrons moves in this way. This is clockwise. Cl clockwise, and this is anti-clockwise. This is anti-clockwise. It denotes by this half arrow, this arrow, and it's down arrow. It denotes by plus half, and this denotes by minus half. So here I am telling you that the first three quantum numbers, the principal quantum number, the azimuthal quantum number, and magnetic quantum number tells about the level of the energy, location, shape of the electron cloud, and the orientation of the electron cloud. But the fourth, that is the spin quantum number, the symbol of the spin quantum number is small s, and this tells us that how will the two electrons exist in a orbital. So we will tell you, because when this positive, this electron, when a charged particle moves around the axis, it generates a magnetic field. So this magnetic field is, and this magnetic, both the magnetic field are opposite to each other. And the magnetic field generated by the clockwise electron and the magnetic field generated by the anti-clockwise electron will be opposite of each other. So both the electron may exist in a particular orbital. In this way, this tells us this is our spin quantum number. So I think I have explained you about the four quantum numbers. I think that you have understood about the quantum numbers. How will you now? I will make you a chart of the how will you to find the value of different orbitals, the five orbitals, and the value of n, l, m, and how will you find the value of n? I will tell you about for the four quantum numbers. So here again I am telling you that here this is n, this is n, this is l, this is m, and this is s. So I will give you. Suppose that we have taken the quantum number 1, the value of quantum number, the value for 1, the L will be 0. So I will write here L is equal to 0 to n minus 1. N minus 1. So here when the value of n, you will write here 1 minus 1, 0 to 0, you will write here n. Again the value of n is equal to plus L to 0 to minus L. So here it is only 0, so the value of 0. So the value of 0. So again, and then S, there are 2 electrons. So this electron will be half positive and this will be half. So the value of this electron here, it is 0, 0 and 0. In this way, it is S1, S2. It is 1, S2. So these are the values of the the quantum numbers for the first S and the first event. So 0, 0. Now, when I will ask you about all the 4 quantum numbers are not equal for any electron. So again, now calculate the 2. Suppose here is 2. So calculate the value of L, 0 to n minus 1. So the value of 0, it is 0 and the value is 1. There are 2 values for the 2 electron for the L, 0 to n. Now calculate this 0. Again it is 0, plus half, and for 2 it is 0 and it's 0 minus half. This is 2s2. For 1, when L is equal to 1, then find out the value of M. So plus 1 to 0 to minus 1. So here you will write plus 1, 0 and minus 1. This is 4, 1. This is 4, 1. So here you will write here. This is 1 plus 1. So here you will write plus half and minus half. For this, plus half and minus half. And for this, plus half and minus half. In this way, this is P6. There are 6 electrons. This half shows this is clockwise, this is anti-clockwise, clockwise, anti-clockwise. These are the scalar. So I have told you about the orbitals, the different types of the quantum value of the different quantum for the cell, for the cell, second cell, or for the second quantum number. Now I am going to tell you about the third cell. So here you will write here 3. So when n is equal to 3, find the value of L. We will find the value of 0 and this is 1 and this is 2. 0 to 3 minus 1. 3 minus 1, this means 0 to 2 minus 1, 0, 1 and 2. Again, you will find here the L, it is 0 and it is also 0. So you can write here 3 and 3. So here plus half and minus half. In this way, here you can write here this is 1. So this is 1, this is minus 1 and minus 1, 0 and plus 1. 0 and plus 1. You can write here in this way plus half and minus half. And for this plus half and minus half. And for plus 1 it is plus half and this is minus half. Now it is all, this is the 1, this is plus, this is minus 1, this is 0 and this is plus 1. Now I think that you have noted. Now I will tell you about the second 2 and 2 will be here. So this is all about 3. You can write here this is 3. The values of 3 again 0, 1, the same value will be here. Then the value minus 2, minus 1, 0, plus 1 and plus 2, and in the same manner you will write 1, 2, 3, 4, 5, and in the same manner you will write here minus 2 in this way, plus half, minus 1, plus half, minus half, and 0 again minus half. So you can write in this way. So in this way you can find the value of all types of the quantum numbers. You can make a table of this, the table about the values of quantum numbers. So that's all for today. I think that you have understood the importance of the quantum number. Quantum numbers describes us the energy and the location of the electrons, and furthermore the magnetic and the azimuthal quantum tells us the shape of the electron cloud and the orientation of the electron clouds. In this way, if I ask you what is the electrons in the third cell and fourth cell, second cell, how will you find the value? You can easily find the values of different quantum numbers with the help of this table. The video is very useful for you. Please try to understand about the quantum number. That's all for today. And also, please like it, share it to your friends, that they can also understand by watching this video. Thank you very much.